So we've just used our limit laws to find out that the limit of the function y equals 3x as x approaches 1,000 is equal to 3,000. And we got this because if we have two functions that are added together, we can just calculate those limits separately and put them back together. That's fine, as long as the limits exist separately. Now, I'm not going to be using this technique every single time, right? I calculated what's the limit of 3 times x as x goes to 1,000. Is that going to work as well when I'm calculating what's the limit of 1,000 times x as x approaches 3? Probably not. And that's okay. That's not how I actually calculate limits day to day. What I know is that the limit of x as x goes to 1,000 is 1,000. That was limit law number 8. Or the most important one, at least if I was writing the textbook. And I can also say the limit of the function y equals x as x approaches 3 is 3. So I can use the same idea. I'm not going to write out the letter x 1,000 times, but I can just use the same reasoning to say that this limit should also be 3,000, right? I would have 1,000 different limits. They're all going to 3, and I just add them all back up together. So I'm going to keep with this theme of going slightly out of order from the book and introduce limit law number 3. So if c is a constant, then the limit of c times f of x as x approaches some coordinate a is equal to c times the limit of f of x as x approaches that same coordinate a, and again, this is only so long as f of x actually has a limit. So limit f of x, x approaches a, exists. So now I can do this trick for any constant I find inside a limit. What is the limit as x approaches 7 of the function, let's say, minus 3 times the square root of x? Well, since minus 3 is just a constant, I can pull it outside of the limit by itself. Excuse me. And then I will multiply negative 3 onto the value of the limit of x, of square root of x as x approaches 7, like so. And so I can use this on any constant, positive, negative, rational, irrational, they're all good. Briefly, what was that other limit law I was skipping to get here? The one that I claim is slightly less important. They're all good. They're all very good laws. That is if I calculate the limit not of the sum of two functions, but of their difference. So limit of f of x minus g of x as x approaches a. This will be equal to the limit of f of x minus the limit of g of x. That should be a g. And these should be for x approaching the same coordinate in both places. We calculate these limits if they exist, and the difference of these two is the value of this limit. Why do I say this one is less important? Because if I have rule number 1 and rule number 3 together, they're going to combine to give me rule number 2. Be back in a minute.